Good morning, friends. Good morning.
Morning, sir.
Good morning, sir.
Yeah, take down this problem. Adaptive resonance theory. Problem alone you take. Taken. Taken the problem. Okay. What is given in the problem statement? We need to find out the computation for this ARC network. So what we need to do? So they have given a ARC network with 7 inputs, n equal to 7, and initially one output neuron, n equal to 1. So this may be the first input vector, second input vector, third input vector, fourth input vector, and fifth input vector. Okay. So first the input vector, we have 7 neurons, 7 input neurons. So 1, 2, 3, 4, 5, 6, 7. So like that. So we have 5 input vectors. For all the 5 input vectors, so we have 7 neurons. And they have given the vigilance parameter rho equal to 0.7. Vigilance parameter rho equal to 0.7. So what is the first step? What is the first step in the algorithm? So I need to initialize the each top-down weight TL, J of 0 equal to 1. 0 is nothing but my old value or the original value. Initialize each top-down weight TL, J of 0 equal to 1. So that step first I need to do. So step number 1, initialize all the top-down weights are set to TL of 1, IL, 1 of 0 equal to 1. So that I need to initialize. And the second step, initialize the bottom up weights BJL of 0 equal to 1 divided by n plus 1. BJL of 0 equal to 1 divided by n plus 1. That is the second step. So I initialize all the top down weights as 1 and all the bottom up weights are set to B1 of B1 comma L of 0 equal to 1 divided by 1 plus 1. So 1 plus n. So what is n? N is nothing but 7. So 1 divided by n plus 1 equal to 7 plus 1 equal to 8. Is it clear now up to this step?
Yes, sir. Yes, sir.
Okay. So next step. So we need to present the first input vector. We need to present the first input vector. So what is the first input vector? So it has 7 neurons. So 1, 1, 1, 1, 0, 0, 0, 0, 1. So it has 7 neurons in the first input vector. Okay. So for that, okay. So this is my first input vector. So for that, what I need to do as per the algorithm. So I need to active the set A containing all nodes and I need to calculate Yj. I need to calculate the Yj for the first input vector using this formula. Yj equal to Bj comma 1 into x1 plus Bj comma n into xn. Like that we need to calculate. So this is the formula. So that is the formula. Using this formula, I need to calculate. So what is this B value is nothing but 1 divided by 8, which has been calculated in the previous step. B is nothing but, what is B? Bottom up weights. B is nothing but bottom up weights, which is calculated as 1 divided by n plus 1, which is nothing but 1 divided by 7 plus 1 into 7 plus 1, that is nothing but 1 divided by 8. So that is nothing but B. So this 1 by 8 into x1. X1 is nothing but this value. So totally 7 neurons are there. This value is nothing but 1. Again plus 1 by 8 into the second neuron. Then 1 by 8 into third neuron. Then 1 by 8 into fourth neuron. Then 1 by 8 into fifth neuron. 1 by 8 into sixth neuron. 1 by 8 into seventh neuron. So 1, 1, 0, 0, 0, 0, 1. So all the 7 neurons has been included here in this particular equation Yj. So totally 7 neurons are there. So we need to go for 7 times. So once you simplify, you may get the answer as 3 by 8. Once you simplify, you may get the answer as 3 by 8. Is it clear? This step?
Yes, sir.
Okay.
Yes, sir.
Okay, now we need to compare this with the threshold. We need to compare this with the threshold. So usually threshold is set as 0. Usually threshold will be set as 0. So it is greater than the threshold. Y1 is greater than the threshold. It clearly indicates that Y1 is winner. It clearly indicates that Y1 is the winner. So since Y1 is considered as winner and there are no competitors, we need to compare the similarity between S star and X. S star and X. Why? Because so the first portion of the input layer is nothing but your S. Then from S we are mapping it to X, second portion of the input layer, and then it goes to the output layer. So input layer you have two divisions. First divisions is represented by S. So that is nothing but we are saying that we need to compare the similarity between S and the X with the input vectors, whatever we are trying to supply. So for that we need to use this formula. So summation of TL comma 1 into XL divided by summation of XL. So what is this TL of 1 is nothing but your top down weights. It is nothing but your top down weights, and this is nothing but your bottom up weights. So this is nothing but my 1 value. This is nothing but my 1. So 1 into 1, okay, plus again 1 into 1 plus 1 into 0 plus 1 into 0 plus 1 into 0 plus 1 into 0 plus 1 into 1. So this becomes 0 and this 1 plus 1 plus 1 is nothing but 3. Divided by, so XL is nothing but I am going to sum up all these things. 1 plus 1 plus 0 plus 0 plus 0 plus 0 plus 1. So again I may get a value as 3. So 3 divided by 3 equal to 1. It is greater than the vigilance parameter called rho. It is greater than the vigilance parameter rho, which is having a value of 0.7. So the vigilance condition is satisfied over here, and we need to update the new weights as per this algorithm steps. So vigilance parameter is there, then we need to update the new weights. So Bj star L of new equal to this formula, and this is for bottom up weights and this is for top down weights. So we have two weight values. One weight value is bottom up weights, other weight value is top down weights. So we need to perform that weight updation calculation. Okay. So how to perform the weight updation calculation is using that formula. So what is that formula? So that is nothing but, so what I shown in the previous slide, Bj star into L new equal to, that is nothing but bottom up value. So which is equal to TL, sorry, nothing but TLJ into old value into XL divided by 0.5 into summation of that formula. So if you apply that formula, so you may get B11 of 1. So first input I am considering. So first input vector I am considering. For that I need to calculate B11 of 1. So B11 of 1 equal to, so what will be the equation over here? So this equation. So for example, this is the equation. So TLJ star, that is nothing but here it is 1. TLJ star old equal to 1. Again, what is X value? The first value is nothing but 1. The first value is nothing but 1 divided by 0.5 into summation of TLJ star old into X value. So again, you need to consider all the TLJ star old equal to 1 value. That is nothing but your top down values. It is 1. So 1 into 1 plus again 1 into 1 plus 1 into 0 plus 1 into 0 plus 1 into 0 plus 1 into 0 plus 1 into 1. So if you simplify, you may get the value here as 3. If you simplify, you may get the value here as 3. Okay. Then again, you may have 0.5 is also there. So 0.5 plus summation of this value. So it is 1 divided by 3.5. This is for B11 of 1 alone. Okay. Next, similarly, you need to calculate B12 of 1. B12 of 1 you need to calculate. So once you apply that in the same formula, B12 of 1, you may get the same value. Why? Because here also I have the input neuron value as 1. So it is 1 divided by 0.5 plus 3. So you may get 3.5 also for B12 of 1. Then B1, 7 of 1. So this last entry, B1, 7 of 1, you may get only this 1 divided by 0.5 plus 3, it is 3.5. And if you take this third value and this fourth value, fifth value, and sixth value, that is nothing but first input vector. This one represents first input vector and first neuron. First input vector, second neuron. First input vector, seventh neuron. Here also you take first input vector, third neuron is nothing but value assigned as 0. So it is 0. Then first input vector, fourth value is 0. First input vector, fifth value is 0. First input vector, sixth value is also 0. Since all these values are 0, so 0 divided by 0, you may get value as only 0. So that's why for the third, fourth, fifth, and sixth, you are getting a value as 0, and first, second, and seventh, you are getting the value as 1 divided by 3.5. 1 divided by 3.5. So now, since my weights have been updated, so what I need to do is nothing but I need to construct a new, I need to construct a new bottom up weights. That is nothing but, so this is not clearly coming up. So this is nothing but B of 1 equal to 1 divided by 3.5 for the first entry. Second entry 1 divided by 3.5. Third is 0. Fourth is 0. Fifth is 0. Sixth is 0. And seventh is 1 divided by again 3.5 will be there. So that is my new bottom up weight matrix. Is it clear now up to this point? Any doubt? Any doubt?
No, sir.
Yes. Next one. So now we have updated only the bottom up weights. Now we need to update the top down weights also. It is TL comma 1 of 1 first vector equal to TL of TL comma 0 of O into XL. That is the formula. So we are trying to use this formula. This is new weight and this is nothing but your old weight value into XL. So old weight value into XL is nothing but it is 1. Again into XL value is nothing but 1 into 1 into 1 into 1. You may get it as only 1 only. So 1 into 1, 1, 1 into 1, 1, 1 into 0, 0, 1 into 0, 0, 1 into 0, 0, 1 into 0, 0, 1 into 1, 1. So you may get this one value. So this is nothing but your top down weights. So this matrix is represented as top down weights. So now first learning vector we have completed. So now we need to present the second learning vector. We need to present the second learning vector. So what is the second learning vector? So it is 0, 0, 1, 1, 1, 1 and 0. So same procedure we need to apply. I need to find the input. Input like Yij, that is nothing but input of output neuron. Okay, so Yj, same formula I need to use. So I need to calculate. Can you do it, please? Can you do it for second input vector? So what will be the output? It is second input vector. So now you should not use a 1 divided by 8. 1 divided by 8 was initial bottom up weights. Now the new bottom up weight is nothing but 1 divided by 3.5. 1 divided by 3.5. So you need to put it as 1 divided by 3.5 into this x value. X1, this x value. Then 1 divided by 3.5 into this 0. Then again, the bottom up weights value is here 1 divided by 3.5, 1 divided by 3.5, 0, 0, 0, 1 divided by 3.5. So the same you need to use. So 1 divided by 3.5, 1 divided by 3.5, this is 0, this is 0, this is 0, this is 0. So 3, 4, 5, 6 is 0. So it becomes 0. And again, these two positions you get 0 and this position also you get 0. So ultimately it is 0. So again, y is winner. Because it is equal to threshold, it is y is winner. So however, this time we do not reach the vigilance threshold. However, this time we do not reach the vigilance threshold. So we need to equate, no, or we need to map this S star into your X value. So for that, you need to use this formula. The second step, summation of TL1 of XL divided by summation of XL. So what is the TL? What is the TL value? TL is nothing but my new value. TL is nothing but 110000. This is nothing but my TL value. So that you apply over here, and the XL is nothing but this value, second input vector. So it is nothing but 1, 1, 1, 1. So this is nothing but 4. So in the numerator portion, you get 0, 0 divided by 4 equal to 0, which is less than the threshold. So we do not reach the vigilance threshold, it is 0 over here. So this means that we need to generate a second node in the output layer that represents the current input. That is nothing but it does not fit or it does not map to the existing cluster or existing group or existing division. So we need to generate a second node in the output layer that represents the current input. Therefore, top-down weights of the new node will be identical to the current input vector. Top-down weights of the new node will be identical to the current input. Since it is not matching this vigilant threshold or reaching this vigilant threshold, so we say that it does not belong to that particular cluster. So we need to create a new cluster that is considered as second node in the output layer, and the top-down weights of the new node will be identical to the current input vector. Is it clear? Is it clear? Any doubt? And next, so I need to compute the weight matrix over here. I need to compute the weight matrix over here. So it is nothing but again 1 divided by this one. Okay. N plus 1. What is N? N is nothing but here. What is N? N is nothing but here 3.5. So 3.5 plus 1, it is 4.5. So again, I am going to update over here. So it is becoming as the 0, 0, 1 divided by 4.5, 1 divided by 4.5, 1 divided by 4.5, 1 divided by 4.5. So put together 0. Then again, I need to calculate the top-down weight values. So top-down weight values for the second input vector, the same value you may get because it is 1 into 1. So the same value will get 1, 1, 1 and 1. Is it clear?
Yes, sir.
Then third input vector. Similar procedure you need to follow. Third input vector. So third input vector is nothing but, so this is nothing but your third input vector with 7 neurons. Again, we need to calculate the same formula. We need to calculate the same formula. Okay. So what is that formula? So first one is nothing but here we have two things. So this might be y1 and this is nothing but your y2. This is y1 and this is nothing but your y2 in the bottom up weights from the input layer to the output layer. So here for y1, if you calculate, what is y1? Y1, if you calculate, it is nothing but 1 divided by 3.5. So first position, second position, and seventh position. So 1 divided by 3.5 into 1. So into 1 plus 1 divided by 3.5 into 0 plus 1 divided by 3.5 into 1 plus 1 divided by 3.5 into 1. Again 1 divided by 3.5 into 1, 1 divided by 3.5 into 1, again 1 divided by 3.5 into 0. If you simplify, you may get 1 divided by 3.5. You may get a 1 divided by 3.5. Why? Because the second becomes 0, this becomes 0, this becomes 0, this becomes 0, this becomes 0, and seventh becomes 0. So y1 will be 1 divided by 3.5. Again, y2, if you take first and second position is 0 and seventh position is 0, 3, 4, 5, 6 is having a value 1 divided by 4.5. That is considered as y2. So y2, if you calculate, so it is 0 plus again 0 plus 1 by 4.5 plus 1 by 4.5 plus 1 by 4.5 plus 1 by 4.5 plus 0 only will be there. Okay. So if you simplify that, you may get it as 4 divided by 4.5. That is nothing but it is 0.8. 4 divided by 4.5 is nothing but 0.8 here. Okay. And it is 1 divided by 3.5, it is 0.2. 1 divided by 3.5 is 0.2 and 4 divided by 4.5 is nothing but 0.8. So now I need to find out which one is the winner. So whether 0.28 or 0.88 is the winner. And comparing these two clusters, y1 and y2, y2 is having a higher value as 0.8 and y1 is having a lower value as 0.28. So this clearly indicates that y2 is the having a higher value is considered as the winner, and this time we exceed the vigilance threshold. This time we are exceeding the vigilance threshold. So this next procedure is nothing but, so we need to apply that in the particular formula. This formula, that is nothing but mapping from S to X, we are trying to do it. So once you do that mapping by X to this, so you may get it as 0 into 1. What is that? 0 into 1. This one. Since y2 is winner, this you need to take. Okay. 0 into 1 plus 0 into 0 plus again 1 into 1 plus 1 into 1 plus 1 into 1 plus 1 into 1 plus 0 into 0. So it is ultimately 4 divided by 5. So how many ones are there? Bottom portion 5 ones are there. So 4 divided by 5, it is 0.8. It is greater than the vigilance parameter. So we are exceeding the vigilance parameter. So we adopt a second node's weight over here. So each top-down weight is multiplied by the corresponding element of the current input vector. Similarly, I need the new units bottom-up weights are set to the top-down weights divided by this value 0.5 plus 0 plus 0 plus 0 plus 0 plus this one 0 plus 0 plus this is nothing but my input pattern. Second input pattern I am trying to consider as it is 0 plus 0 plus this one. Second input pattern I am considering over here. So it is 0 0 1 1 1 1 and 1. So this value is nothing but 1 2 3 4 4.5. So I am getting here it as same thing 4.5 and the same T3 is also same thing I am obtaining over here. And for the fourth input I need to perform the same function I need to perform for fourth input. So what I may get so y1 is nothing but this value 1 divided by 3.5, 1 divided by 3.5, 0 0 0 0 and 1 divided by 3.5. y2 is nothing but 0 0 1 by 4.5, 1 by 4.5, 1 by 4.5, 1 by 4.5 and again it is 0 over here. Okay. So the same y1 I need to substitute over here. So what is the value over here? It is nothing but y1. The first is again first value is 0, so it becomes 0. Second value is 0, again it becomes 0. Third value is 0, it becomes 0. Fourth value is nothing but 1 into 1 divided by 4.5. It is 1 divided by 4.5 plus 1 by 4.5 plus 1 by 4.5 again plus 0 will have. So what you will have with respect to y2, it is nothing but 3 divided by 4.5. With respect to y1, you get first value as 0, second value as 0, third value as 0, fourth value, fifth value, sixth value, and seventh value. Why? Because the first two values are zeros for input neurons, and third, fourth, fifth, sixth values are zeros for the weight values, and the seventh value is zeros over here. So ultimately, y1 will become 0 over here. So again, comparing these two values, 0 and 3 divided by 4.5. So which one is greater? This one will be greater. 3 divided by 4.5. Again, y2 is winner. Then I go for a vigilance test. So vigilance test, again, I consider that TL of 1 TL comma 2 of x1 divided by summation of x1. So I have only 3 ones here, and again it is 1 over 1. It is again 3 divided by 3. It is exceeding the vigilance parameter. So we adopt the second node's weight itself. So as usual, each top-down weight is multiplied by the corresponding element of the current input. So second, the new weights are set up to the top-down weights divided by the this one previous weight values. I am considering as it is 0, 0, 0, 1, 1, 1, and 0. I am adding it up with the 0.5. So this gives the new weight values. So it is 3 and plus 0.5, it is 3.5. And again, the top-down weights remains the same because it is only 1, 1, 1. Then fifth input vector, I am going to see this is my y1 value and this is my y2 value. So if y1 and y2 value, so if I substitute in the formula, so I may get 2 divided by 3 by 5, and here it is 3 divided by 3 by 5. Again 2 by 3 by 5 or 3 divided by 3 by 5, which is greater. Again, once again, y2 is considered as the winner, and vigilance test again here fails. Why? Because this is less than the threshold value 0.6. This means that so active set A is reduced to contain only the first node, which becomes the uncontested winner. This means active set A is nothing but the first input node, is reduced to contain only the first node, which becomes the uncontested winner over here. Again, I go with the vigilance test for the fifth input vector. So it is 2 by 5 in simplifying. So once I simplify, it is 0.4, which is less than 0.7. So I need to create a third output neuron, which gives the following new weight matrix. So what is the value here? So here it is third means already it is having 4.5 plus 1, it is 5.5, 5.5, 5.5. I may get it over here. And again the T5 matrix I am getting over here. The same formula I am using it up. Then up to this, the first approach completed. Then second approach is nothing but the second iteration. Second iteration, I am trying to present my first input vector. This may be my y1, this may be my y2, and this may be my y3. Same procedure I am applying 3 divided by 3.5, 0, 2 divided by 5.5. I am checking for the vigilance test. It is succeeding. So my current input is identical to the winner's top-down weights, and no weight updation happens over here. Again, second input, same formula I am using y1, y2, y3. I am checking for vigilance. It is again succeeding. So no weight updation occurs. Then third input, again y1 I am calculating, y2 I am calculating, y3 I am calculating, but here I am considering among this y2 is winner, but vigilance test fails for here. So again, this means that the set active set is reduced to A. This is nothing but 1, 3. Active set is reduced to A, which is nothing but 1, 3. That is nothing but the first node and the third node is alone winner. And since y3 is greater than y1, the third node is considered as the winner over here. So with this, we are going to follow the vigilance parameter. Again, for the third node, vigilance parameter satisfies, and then I am trying to update my weight values with the same formula. And then for the fourth vector, then for the fifth vector, I am trying to repeat. So fourth vector, it passes the vigilance test. So no weight changes occurs. Fifth vector, it makes second unit to win, which fails the vigilance test. Then the new winner third output neuron, which is passing the vigilance test, must not lead to any weight updations. So again, if the second approach has been completed, if it is required, third iteration, fourth iteration, fifth iteration has to be done. So the conclusion here is nothing but So art must be able to adapt to changing environment, but constant change can make the system unstable. So if it is changing in a constant manner, it makes the system in an unstable manner, but it learns new information. Only it forgets the previous information it has been learned so far. So with this, the art network is completed. Any doubt? So I will upload the slide. Already I have uploaded, I think. So you can go through the slide. If you have any doubt, you can clarify me in this class or in the next class. Shall we continue with the next topic? So it is next topic is learning vector quantization, LVQ. Learning vector quantization is nothing but it is different from vector quantization and coherent self-organizing map. And it is basically a competitive network which uses the supervised learning algorithm like a coherence and the what is that art network. Okay. So the architecture here is this one. Sorry. So the architecture here is nothing but it is a fully connected architecture. So we can see n number of input units and m number of output units as we saw in the previous art network. Same architecture is followed over here. So what are all the parameters used in LVQ is nothing but x again is considered as the training vector and t is nothing but class for the training vector. And Wj is nothing but weight vector for jth output node, and Cj is nothing but class associated is nothing but the cluster associated with the jth output unit. And training algorithm, it is very simple. Step number 1, I need to initialize the reference vector, which can be done as follows. Step 1a. So from the given set of training vectors, I need to take first m number of clusters, training vector, and use them as weight vectors. And remaining weight vectors can be used for training. So first m clusters are used as weight vectors and remaining vectors are used for training. So if you take in the art, we have first 5 input training vectors has been given. Among that 5, first vector may be considered as the weight vector over here, and rest can be used for training vector. And step 1b is nothing but I need to assign the initial weight and classification randomly. So initially I may assume the initial weight and the classification as a random manner. Then I try to apply the k-means clustering method. K-means clustering method, what you covered in your data mining or data warehousing concepts, that k-means clustering you need to apply. Then step number 2, I need to initialize the reference vector alpha. Then step number 3, I need to continue the steps 4 to 9. And step number 4, I need to follow 5 to 6 for every training input vector. That is nothing but I need to calculate the square of Euclidean distance, j equal to 1 to m, and I takes the value 1 to n. Square of Euclidean distance is nothing but xi minus wij. So x is nothing but the training input vector, and wij is nothing but the weight values associated to that. So for this, I need to take the square of the Euclidean distance, and then in step number 6, I need to obtain the winning unit j. That is nothing but if this dj is minimum means, then I consider that as an winning unit, and then I try to calculate the new weight based on the winning unit by the following equation. If t is nothing but your target, if t is equal to cj is nothing but your classification or cluster, cj, then wij new equal to old value plus alpha into x minus wj old. Alpha is nothing but again learning rate, and tj is not equal to cj means, then this new updation weight new value will be old value minus alpha into x minus w j old value. And again alpha here is also learning rate. And step number 8, based on this, I need to reduce my learning rate alpha. Then I need to test for the stopping condition. If it is satisfied, then I am going to terminate. If it is not satisfied, then I try to repeat the process. That's why they said that maximum number of approaches reached if my testing condition is stopped. test for stopping condition, then learning rate reduced to a negligible value, so that I can able to converge my network at an earlier stage or at a minimum number of iterations. This is my flow chart. First one, I need to start, then initialize the weights and learning rate. So for each input vector S, I need to obtain the winning unit index J for by calculating squared equivalent distance, and if it is minimum, then that is considered as declared as winner, and then for that I need to find whether target is equal to that cluster value. If it is yes, I'm going to update my weight values. If it is no, I'm going to update the weight values using this formula, and I'm going to reduce my learning rate alpha using this formula, alpha of t plus 1 equal to 0.5 alpha into t. If alpha reduces to a negligible value, then I am going to stop my iterations. If not, then it may be repeated over here. So I'm once again, I'm going to repeat the process. If it is yes, it follows this. If it is no, it goes over here for reducing the alpha values. So what are all the various variants of LVQ, linear vector quantization? So there are various variants, LVQ2, LVQ2.1, LVQ3 have been developed by Kohinen also. The complexity in all these three variants is due to the concept that how the winner is selected as well as the runner-up unit. Winner is nothing but the first one, and the second person is considered as runner-up unit will learn. So based on the winner, how the runner-up will learn and how it tries to help us in converging the neural network during the iteration process. So LVQ2 also we use the same parameters. X is current input vector, YC is reference vector close to this XA, YR is other reference vector which is next closest to one. So this may be the first person, this may be the second person, and DC is nothing but distance from X to YC, first closest reference vector, and DR is nothing but the distance from the first closest vector to the input to the second closest reference vector. And then if the input vector falls within the window DC divided by DR greater than 1 means it falls within the window means, so it has to be within this range. This 1 minus theta and dr divided by dc should be greater than 1 plus theta, and dc divided by dr should be greater than 1 minus theta, and theta is nothing but number of training samples. So how many samples I am going to use, whether I am going to use 1 sample, 2 sample, 3 sample, or 10 sample, or 100 samples. So after that I need to update the weight values. Once I found that it is winner, then I'm going to update my weight values using this formula. If it belongs to a different class, I'm going to use the weight updation formula, the first formula. If it belongs to the same class, I'm going to use the this particular formula, and again alpha here is nothing but my learning rate. This is for the first cluster, and this is for the second cluster, second nearest cluster. Then again LVQ 2.1. So again we will take two closest vectors YC1 and YC2, and the condition for the window is as follows. So DC1 divided by DC2, DC2 divided by DC1 should be always greater than 1 minus theta, the minimum value, and this one again should be less than 1 plus theta. These two conditions we are maximum. This is for minimum condition and this is for maximum condition. So based on that, I am going to update my weight values. If it belongs to different class, first formula. If it belongs to the same class, I am going to use the second formula, and alpha is nothing but my learning rate over here. Then LVQ3. So again we took two closest vectors. So minimum of this is nothing but 1 minus theta into 1 plus theta. Theta approximately we assume that it is 0.2. And again, based on the winner, I am going to update my weight values, either it is C1 or C2. So I'm going to update my weight values, YC1 of t plus 1 and t plus 1. So different class, first formula, same class, it is the second formula. And here we may have one more constant called beta, which is nothing but multiple of learning rate alpha, and beta value takes the value m into alpha into t, where m takes the value between 0.1 to 0.5. So with this, we will wind up. I will upload these two slides in the Teams. So till now, what was taught, that is for your CAT 1 exams. Okay. So our CAT 1 exam falls on Sunday, no? The first exam, A1 slot. Am I right?
Yes, sir.
Yeah. So till now, what has been taught up to this third module? So it will be for the examinations, Cat 1 examinations. Okay. So I will conclude the class and I will wind up the class.